Okay, so I decided that I was going to buy myself a solar power bank. Not one of the smaller ones like I bought previously. I thought it'd be a good idea to buy a larger power bank that I could run stuff around the house or out and about. I've had a few jobs recently where I've needed to power a reasonable amount of equipment while I've been on a client site out somewhere away from any mains power. So I thought about time to get something with a bit of heft to it. So I've sort of known about Bluetti power banks. I don't know what's going on with my camera. Sort of known about Bluetti power banks and solar generators for quite some time. EcoFlow and some of the other manufacturers. I've used all powers, smaller 200 watt hour inverter based power banks for a little while. So I spent a lot of time researching what to get, and I was going to buy myself a Bluetti AC200 Max. And then just as I was about to hit the button to order it, reviews started to appear online for the AC200L, which integrated the plug-in battery charger unit into the device, so you could do proper UPS pass-through on it, and a few other features. They removed the wireless charging pads on top and introduced a 48-volt direct battery connector as part of the features on it. But like I said, I was going to buy the AC200 Max, and this one came out, and I thought, actually, that's a better fit for me. I can use it for taking to site, plugging in and running some stuff, or what I actually want to use it for most of the time at home is using its timed UPS feature. So it'll click on and run off a battery during peak rate electric costs, and then it'll flick back onto the mains during low rate and recharge the batteries. I run some servers and some network kit at home, QNAP, storage array, and IoT devices and stuff in my little server cupboard, and that draws quite a lot of power. And I would like to find a way to use it's not make me use less power, but I hope to optimise the cost of it. If it can run the kit on the mains during cheap rate time, and then on the battery during the peak rate times. Where I live in Guernsey, you kind of get two cheap rate bands in the day. You get 10 hours overnight. I don't know, from say 10 o'clock at night till whatever o'clock in the morning. But you get 2 hours in the middle of the day. So what I'm hoping is at 5:45, when my peak rate starts, the Bluetti will run on its battery until about 1 o'clock, when my cheap rate starts for 2 hours, and then it can it'll boost the battery back up again for it to then run on the battery until the evening peak rate starts at 7:45. So what I want to do first is take a quick look at the unit, how it arrived, and talk about the price and shipping, especially since it was to Guernsey. I was promised a VAT refund that hasn't materialised yet, because we don't pay VAT in Guernsey. Shipping was quite expensive because it cost an extra £100, but we'll talk about that later at the end. And I want to go through and test what the actual round-trip efficiency of the unit is. On the Bluetti website, it's about 20% inefficient on the what they call the round-trip efficiency, so it's 80% efficient. You're losing 20% in losses. That's the electricity that's used by the Bluetti and is lost in the conversion to DC and then the conversion back from DC to AC. So I want to test that and find out what that's like. Also going to take a brief look around the unit and show you the AC200L, the UK version, because all of the units I've seen online and on reviews have been the US version. So we're going to take a look at the plug socket arrangement on the front with the 240 volt, because we're 240 volt in the UK, with 240 volt British sockets. So what I'll do is I'll pull up the pictures on screen now. This is the way the unit came boxed. from Bluetti. It's fairly well boxed, and you've got the yellow straps that go all the way around to stop the packaging from coming apart. You can actually pick up the unit, which is really heavy, from these straps, and once you cut these straps off, you're left with another box. Inside the box there's another box. Seems to be the way stuff gets shipped these days, box within a box. You can just see on the top here that the 240 volt one is ticked here. So moving on to the next picture, there's an interesting notice on the top that says return cannot be accepted without this box. So I have to store this box, because if it ever needs to go back for replacement, or if anything happens with it, it's got to go back in its original box, which is going to be problematic because it is quite a big box. I don't know if I've said the word box enough, but it's a box. It came in a box. You have to keep the box. Let's look at the next picture. In the box is a bag, and that bag's got the accessories in. So there's a little void in the top of the foam, so the bag sits between the foam and the outer edge of the box. So that's the foam, and then under the foam is the unit, which is wrapped up in a small bag. Yep, that's about it. And then you lift it out, and it's very heavy. And just pause the video here, and then we'll move on to the videos of me showing around the unit. Just a word on the weight. It is very, very, very heavy. It's called a portable power station. I would argue it is more of a transportable power station, because portable to me is something that you can pick up, walk about with, or you can pick up and walk a distance with. You can pick up a portable device like a portable saw and walk 100 yards of it without having to put it down. This unit is heavy enough that if you pick it up, you're not going to want to walk more than 20-30 meters before your arms are going to start to hurt and you're going to want to put it down. So I'm actually looking at a little sack truck for this. Just an aluminium collapsible sack truck to move it around. If I had to move it any distance, I wouldn't want to be carrying it. If I had to carry it any distance, I would want two people on it, one holding each handle, carrying it between you. I think that's the only way you could move this any real distance. So that said, let's get on to the videos of me showing around the unit. So this is the UK version of the Bluetti AC200L solar power station. It's exactly the same dimensions as the more common US one that you see reviewed on YouTube quite a bit. Just taking a look at this inside before, and the bottom two power outlets are the correct way up, but never seen this before. The top two power outlets are upside down. That's not normal for UK outlets. In the top of the back box it came in was a bag with some connectors and things in. They're all bundled there together, so it's solar input leads and a power lead that uses the aviation style round type connectors, and the 2-pin for DC power input from solar. I think I'd have preferred to see, a more standard IEC type kettle power lead like you get for computers, but I suppose these are go into these special sockets to allow them to have these screw-on caps and water protection. Protection from ingress of water. But I've seen IEC connectors with screw-on dust caps before, so you're going to have to make sure you keep this cable with you or keep this with the unit, rather than using one of the ubiquitous power connectors that you get with any kind of computer, or piece of network equipment or anything. So we've got a ordinary UK 3-pin mains plug to the 3-pin aviation style connector, a cigarette lighter charger to plug into the XC90 connector. Presumably, yeah. So this is the end. This is the end that gets screwed into the unit, and then you plug your X90 connector into that to plug into your vehicle, or you use your MC4s. These feel like very thin MC4 cables. They feel like they're only single insulated as well, so I'm not sure I want to put 150 volts through this, which is the maximum panel input voltage. I think I'd want something that's double insulated. And certainly not that thin. I think they might heat up if you're running it at full chaff for a few hours. Those I think these will get quite hot, so I'd be inclined to replace this with a high quality cable. Yeah, standard MC4 connectors to the XC or XT90. Yeah. That's a brief tour of the unit. I think the specs on all of the other outputs, like the DC power output for 12 volt lead and the 12 volt, that's the 12 volt 10 amp, that's the 48 volt 8 amp output. These connectors, there's only a few accessories out for these at the moment, or even one I've heard of, which is like a caravan style connector. Gives you an additional solar panel input and DC power out into a caravan. I think there's going to be some more accessories coming up for this in the coming months, so I'll be certainly keen to see what else you can use this for. There's two USB-C outputs, 100 watts, but that's a 100 watt split between the two connectors. So you know, if you've got a 65 watt laptop connected in there, you're only going to get 35 watts out of that one. Yeah, total of 100 watts max, and you get AC, USB-A type connectors there as well. Interestingly enough, on the AC200L, you can turn the USB power on and off separately to the DC. So the DC button here covers these input outputs. USB button here covers the USB connectors. AC is inverter for these four outputs. So yeah. So that's a brief rundown of the outputs. What I'm really keen to do on this is actually to find out what the round trip efficiency is on powering a device, because all of the stats I've seen so far are ratings for the 120 watt, the 120 volt US type inverter. So I want to see what the efficiency is on the new UK version, which is 240 volts. So I'll get on and get this plugged in and fired up now. So I've got it plugged into the mains, and the display on the front of the unit showing 1206, 1207 watts going in. The power meter on the wall is 1246 ish, so there's about 40 watts difference between the two devices, but I'm not sure which of the two meters I trust more. There certainly isn't going to be a 40 watt loss in the cable, that's for sure. I did wonder whether the plugs would sit flat on the unit with the flap going up, but they kind of seem to, although the rubber flap is resting on the strain relief from that connector. So I'm not exactly keen on the idea of having these sockets upside down, but you know, if they were the right way up, then the top sockets would be obscuring the bottom sockets. So I don't think there's an elegant way to do this, really. Maybe one sideways, I don't know. So here we go, the obligatory load test. I've got a 2000 watt fan heater plugged in, and I've got a power meter in, ready to try and empty the unit. And I'm going to run the Bluetti completely out of power using the fan heater. I'm going to measure the amount of power that goes out of it, and then I'm going to measure the amount of power that goes back into it at the mains after to recharge it, and that should give me the figures I need to calculate the round trip efficiency of the unit. So very quickly I'm going to turn on the AC and then unplug the power. So we're drawing about just under 1900 watts. 1900 on the AC output here on the Bluetti, and about 1900 here on the meter. So we'll come back to this in a little while and see if we can figure out what the efficiency is. So it's been about 40 minutes so far, and I've pulled 1.295 kilowatts out of the unit, and I'm down to about 27%. We're still running at about 1867 watts, 1941 on here. So there is a bit of a discrepancy between the two readouts, but I'm going to go from this one, I think. We'll take a look at both actually and see what the difference is. Okay, so we're down to 3%. We've got a little flashing red battery warning sign here. 1.814 kilowatts drawn out of the Bluetti, and that's in about 56.5 minutes. Walk down to 2% now as well. So interesting to see if this does a full hour. It's getting very hot in here though. Okay, so it's an hour and 1 minute and it's just cut out. So I drew 1995 watts out of the unit, and the Bluetti's shut down. So what I need to do is figure out how to reset this power meter. There it goes. And I'll get that plugged into the wall and see how much electricity goes back into the unit. Bluetti has been plugged in on charge now for about 10 minutes, and it's only charging at 363-ish watts. I've just been into the settings on the phone and changed it from standard to turbo and silent and back again, and it's still in standard mode for charging now, but it's only drawing a very small amount of power from the mains. So I wonder if the batteries got warm while it was doing that rundown test. The unit doesn't feel warm at all, but I wonder if the inverter's warm or the battery's warm, or because it's only got 1% of charge in it, it's limiting the battery charging speed to preserve the integrity of the battery. I'll be interested to see if this starts to increase the input power over next few minutes or hours. I'm going to keep an eye on it every 10-15 minutes and see what happens. So I've just had the fan kick in about 7%, and the input wattage has gone up to 774. So I think I was right in that the power input will build as the battery either cools down from the big rundown job it had just now, or it gets out like a danger zone for the battery percentage, maybe forcing 2000 watts into it when the battery's at 5% is potentially damaging for it. So we'll see how this goes. So the device is fully charged now, and it's put 2.515 kilowatt hours of electricity in. I think the time is largely irrelevant because it's been idling for a little while, so I may well repeat the test and see what we get a second time round. Okay, so I repeated the round trip efficiency test 3 times, and I got a consistent result of 79% efficiency. Stated on the Bluetti website it's 80%, so maybe my meter's 1% out, I don't know, but it seemed to be quite reasonable. I remember being told when I was younger that you'd always bank on losing 20% in any conversion, and this is a double conversion. So using my finger in the air, what I've always known as a loss or an acceptable loss, we should have lost 40%, but we're only losing 20, so that seems to be a very good result, and it's in line with what would be a good result from other manufacturers' equivalent products at this range, this price point, etc. Now, whilst I'm on the subject of price point, I bought this unit day one. It was released and I ordered it within 2 hours maybe of it actually going live on the manufacturer's website. I paid about £1,400 for it, and I've had some emails backwards and forth with Bluetti about the cost of the unit, because within a few days of it going on sale it went on an early bird special offer with a cost of about
an indicated previous cost of about £1,700. So here we are, Bluetti website, sale, and I'm going to go through this way, AC200L. So I paid £1,399 for it, and this sale wasn't even mentioned when I placed the order. Nothing there at all. And within a few days of me ordering the unit, I contacted Bluetti about the price and said, "Oh look, I see it's on sale. Any chance of you honouring the sale price?" And they came back and said, "Actually, you paid the sale price." So okay. But what that says to me is that I thought under UK consumer protection legislation that in order for a sale to be valid or something to go on sale, it had to have been sold at this previous price for a period of time before the sale starts. But it was never offered for sale at that price. When I logged in on literally the first day it was sold for £1,399. So this shows me that there may be a bit of a shady practice going on with Bluetti's sale prices and pricing. Now what I'm going to do is get this set up upstairs in the next couple of days on my server equipment at home and get it configured running to recharge itself during the cheap rate electricity and to run on battery during the expensive rate electricity. I'm going to see how that goes. I purchased an additional power meter, so I've got two identical units. How identical I don't know. What I might do some testing on them to figure out how accurate they are between the units, just to make sure I'm going to get a consistent reading between the two, or I'll swap them around halfway through and take a note just to make sure any indifference is evened out. But what I want to do is figure out how much electricity my equipment uses in a 24-hour period, just from the mains, no interference, nothing, just plugged in as is. And then I want to plug in the Bluetti running to optimise my electricity cost by running the gear on batteries during the expensive rate. And it's going to use more electricity, but it's going to use more electricity at a lower rate, so I want to actually figure out what that saving is and whether the cost saving of doing that will ever actually pay for the unit. And it'll also give me an idea of how abusive that is to the battery, how much it's going to eat into those charge cycles. So I'm really keen on doing that. So look out for an updated video in the next couple of weeks. So you know the crack. Like, comment, subscribe. There's some buttons down here somewhere for liking and commenting and subscribing. Yeah, let me know. Cheers.